In this video, we will discuss an application of higher order derivatives. And the typical application is to note that if f of t represents the position of an object at time t, that is, we would describe s as being a position function. Then as we've seen, the instantaneous velocity of the object is the derivative of position. So velocity is s prime. Additionally, the acceleration of the object is going to be the rate of change of velocity. That is to say, acceleration, a of t, is the derivative of velocity, v prime, which is the second derivative of position. It's also important to note that the speed of an object is defined to be the absolute value of the velocity. So the speed is always going to be positive, the absolute value of velocity. Let's look at a very typical example. An object moves along a horizontal coordinate line in such a way that its position is specified by the function s of t. So the really important thing to take away here is not necessarily what the first two sentences are telling us, but just that s of t is the position function of an object. S is measured in feet, t is measured in seconds. So for part A, when we are asked to find the velocity and the acceleration, we just need to remember that velocity is the derivative of the position function. So it is s prime of t. And acceleration is the derivative of velocity. So let's go ahead and first calculate velocity. S prime, going through and differentiating s of t term by term with the power rule. And I'm going to write it above just to make the correspondence a bit easier to see. We have t cubed minus 12t squared plus 36t minus 30. And differentiating term by term with the power rule gives 3t squared. The 3 comes down front, the new power of t is 2. Then we're subtracting away and we have a 12, and the 2 comes down and multiplies by that 12. So 24t, and the new power of t is 1. Plus, and recall that the derivative of a constant times t is just that constant. So velocity is 3t squared minus 24t plus 36. Acceleration is the derivative of velocity, so we're going to just play that same game again. We're going to differentiate the velocity. So the 2 comes down, 3 times 2 is 6, and the new power of t is 1, minus the derivative of 24t is 24, and the derivative of a constant is 0. So let's now look at parts B and C. So when is the object moving to the right? When is the object moving to the left? So this is just a very fancy way of asking. So when is the object moving to the right? That would say when is the velocity positive? To say when is the object moving to the left, we're looking at when is the velocity negative. So we have the velocity function represented above. And what I want to note about that velocity function is each of the 3 terms contains a 3. And if I pull the 3 out, we're left with a t squared minus 8t plus 12. And this velocity function factors nicely. You think 2 numbers that multiply to 12 and add to minus 8. So that would be t minus 2, t minus 6. And for part B, what I would like to know is when is the velocity positive? So for this quantity here, I'm going to put a question mark above it. When is it bigger than or equal to 0? Well, going back to the inequality problems that we encountered in Chapter 0, what we need to do is make a number line and a sign chart. We say, okay, this expression is equal to 0 at 2 and 6. So the expression will be either all positive or all negative in the intervals between and outside of 2 and 6. So we need to pick some test points. We might think 0's in that interval less than 2, 3 is between 2 and 6, 8 is somewhere above 6. So we check what's happening at each of these test points. So when x is 0, we have 3, and I should be careful, it's not when x is 0, it's when t is 0. We have 3 times 0 minus t times 0 minus 6, which is going to be positive. So our expression is positive to the left of 2. In between 2 and 3, we check the point, in between 2 and 6, we check the point 3. So t equals 3 gives 3 times 3 minus 2 times 3 minus 6. 3 minus 2 is positive, and 3 minus 6 is negative. So we're negative between 2 and 6. After 6, we will check the point 8. So if t is 8, we have 3 times 8 minus 2 times 8 minus 6. 8 minus 2 is positive. 8 minus 6 is positive. A positive times a positive is positive. And we've now done the hard work. So if we want to know when is the object moving to the right, we're really asking where is the velocity positive? Well, the velocity is positive to the left of 2 and to the right of 6. So as an interval, that would be minus infinity up to 2, and so union with 6 to infinity. For part C, when is the object moving to the left? That's a fancy way of saying where is the velocity negative? In between 2 and 6. So as an interval, that's 2 to 6, and it's an open interval.